March 1912. This was one of the first designs for Formula A at the time. The vehicle included many flaws, such as a lack of speed and protection, making the driver very vulnerable to impact. Formula 1 first emerged from European racing scene between World War I and World War II, and the sport was originally known as Formula A. It was then changed to Formula 1 in the years after World War II. For example, distances were impossibly long, and drivers and spectators were often killed. Safety remained a concern. In 1975, the Spanish Grand Prix was stopped after 29 laps when a car crashed into the crowd, killing 4 spectators. In this picture, we can see illustrators experimenting with a 6-wheeled car. This did not work as more weight meant more friction and less speed was produced.
This was one of the last pictures taken before a German racer was killed while attempting a world record speed at 82 miles per hour. Viewers might think this is an average speed, but at that time, this speed was still incredibly fast.
Technical innovation and improvements is a hallmark of Formula 1. It takes many millions of dollars in research and development just to improve the performance of the cars even by half a second. Lotus led the way in 1978 with the introduction of ground effects technology, giving the car better grip and downforce. There have been many changes to Formula 1 over the 20th century to the present time. As technology progressed, it became more necessary to change the rules to reflect the increasing capabilities of the vehicles and racers. Recent Formula 1 has been modified in fuel consumption as the car only requires 1 pit stop per race. Compared to the old days, Formula 1 needed 3 pit stops per race to fill up their tanks. The new engines coming to Formula 1 this year are radical. This engine is called Power Unit because its insanely high-tech contraption exceeds the normal tech level. In recent months, there have been plans about creating more spectacular and quicker cars with 1000 horsepower engines for 2017. Beginning this year, teams are trying to downsize from a 2.4-liter V8 to 1.6-liter V6s. At 760 horsepower, this turbocharged hybrid electric engine is one of the most efficient engines in the world. The new hybrid systems are a step up from the energy recovery systems, also known as ERS, we've seen in recent years. It's a whole new breed of racing technology that balances output with efficiency. Various groups such as Mercedes and Lotus that are coming together to set the 2017 rules in terms of the power unit. This is the direction and current status between Formula 1 racing. Just 1 year ago, change has been made where each car requires 40% less fuel throughout the race. The use of side winter carbon energy helps to save more fuel efficiently with the burn of 100 kg of fuel per hour. Less stops increases the chances of winning for the races.
Now let's go to the next part, the specification of the engine! But first, let's see my car collection! Okay guys, now let's go to my garage to see the specification of my collection of cars! This is my first car collection from Gonzaga 1991. I don't know what specification of this car, but you know the spec, you must hear the noise. Okay, engine start! This is not V6! Oh my god! Okay, this is my second car collection. I don't know whether this is V6 or not, but we can see about it. Okay, engine start! My god, this is not V6! Okay, this is my last car collection, and I think this is the most powerful car that I have. I call him Bumblebee Malaysia. I don't know whether this is V6 or not, but we can hear the sound now. Okay, this. Yeah, almost there, almost there. More. Yeah, it's not V6. Oh my god, all of my collection of cars are not V6. Okay, now let's talk about serious matter. Formula 1 V6 engine with hybrid system. Let's go through it. Whoop, whoop. Look at this fabulous hybrid engine with turbocharged V6 internal combustion with 2 motor generating unit, which is MGU H, which specified in harvesting energy from the heat from exhaust, and motor generating unit K, which specified in recovering energy during brake system.
Because balancing the two types of energy throughout the race. Both MGUs are coupled to the turbo engine and packaged within the chassis. MGU-H works as a generator, recovers energy from the exhaust, which exit from the centrally located exits. This energy is passed either to the batteries, where it will be stored to use later in the lat, or MGU-K for kinetic. MGU-K, which is connected to the crankshaft to the engine, acts as a motor and delivers additional power. When the driver brakes at the end of the straight, MGU-K converts to a generator, recovers energy from the braking event. This energy will be stored in the battery for later use in the lab. After the hard braking event, energy speed drops, the rotational speed, the turbo also falls. To avoid turbo lag, when the driver gets back on the power, MGU-H acts as a motive to keep the turbo turning at high speed.
Okay, now let's talk about Newton's 3 laws. The first law is the law of inertia. The second law is force equal to mass times acceleration. And the third law is every action has its own reactions. Newton's first law. A moving object will stay at constant speed in a straight line unless external force act on it. So, in this case, aerodynamics play a very good role. So, aerodynamics will reduce the air friction, which reduce the external force. So, the car can travel faster. Talking about aerodynamics, let me explain a little bit about it. From day to day, aerodynamic technologies develop very effectively to produce more efficient car. The aerodynamics also have been changed to make the car more faster and increase the car safeties. Now, the modification has been made to the front car bumper, the nose part, the rear part, and the horizontal part of the car. Based on calculation, when the car reaches at a higher speed, the downward force produced approximately 1.5 tons to 2.5 tons. These changes been made to increase the downward force to ensure the safety of the driver. The aerodynamic is actually decreasing the drag force, which is the air friction by the wind, and the engine thrust, which is the forward force or the forward speed.
As we can see, the drag flap is one of the part of aerodynamic that decreases the drag of the car. As a result, the speed will eventually skyrocket as less drag equal to more speed.
Therefore, the driver can hit the highest speed to win the race. Now, let's move on to the second law of Newton, which explains the ability of the car to accelerate with mass. To increase the speed, mass must be reduced as the mass inversely proportional to the acceleration, and the force should be increased to boost up or increase the acceleration. Mass can be reduced by using a lightweight component in the car, and the power can be increased by using a high power engine, which produces large force. Now, Newton's third law. Every action will have its own reaction. First, when at the starting point, the friction of the car, at this way, will be at the opposite of the car. The reaction force will push the car forward. So, high friction tires are very important to produce greater forward force.
From this video, the yellow tire represents high grip to the ground, which produce greater frictional force, which produce gigantic forward force that may help the car to have an early lead.
So let's go through this formula. First, centripetal are directly proportional to the product of mass and velocity square and inversely proportional to the radius.
We can see the Ferrari's driver are overtaken by the Red Bulls due to the longer radius to the center as comparison.
Doesn't matter how bad things might seem. I've got the antidote, I've got a reason to